Okay, thanks everyone for attending. My name is David Oaf. I'm the VP of Sales at Preferred Utilities. Today we are going to talk about the most difficult fuel system projects, retrofitting an existing fuel system. The idea for this topic came from a viewer of our last fuel system webinar. He sent me an email complimenting us on the webinar, but he said new fuel systems are easy. It's patching into an existing fuel system that is hard. And I realized he was right. And we hadn't done a fuel webinar on fuel system retrofits because they are difficult and messy and basically we're cowards. But we shouldn't avoid things just because they're hard. So this month we're going to be talking about fuel system retrofits, the most difficult fuel system design there is. We'll take your questions at the end. You can email them to me or type them in the chat box. My email address is on every slide. The most common question we get is, can I get a copy of the presentation emailed to me? The answer is yes, just email me and I will reply with the presentation. Also, Megan will put this video on YouTube in a couple of days where it will live forever. So I tried to break this down into categories, the most common cases that we see. And case one is converting a direct fill system to remote fill by adding main tanks and transfer pumps. This is one of the easier types of fuel system retrofits. That's why we're doing it first. And we've been doing a lot of these in Texas after the freeze we had in February 2021, and customers learned a lesson we've been trying to convey to engineers for years. That is, in an emergency, you can never have too much fuel. So a lot of facilities that had generators with big belly tanks are adding main tanks and supply pumps to increase their diesel storage and their runtime. The first thing we do is we convert the desired runtime hours to gallons of diesel. It's an easy calculation, but people unfamiliar with tanks might forget that you can only fill a main tank to 90% full. And there is some oil at the bottom of the tank that isn't usable as well. The drop tubes don't go all the way to the bottom of the tank. Preferred has a web app that makes this calculation even easier. You enter the generators and their kW, the desired runtime, and the percentages at the top and bottom of the tank you can't use, and it tells you the nominal tank gallons you need. Then you need to determine how many main tanks to use. One large tank is the most economical and may hold enough fuel, but there are reasons why you may want more tanks, including the first reason is redundancy. There are a few things that can go wrong with a main tank to make it temporarily unavailable, so 2 tanks are more reliable than 1. Also, available real estate. It may be easier to fit more smaller tanks than 1 large tank, even if it is a little more expensive. And then finally, there may be transportation and rigging issues. It may be impossible to get 1 large tank to the site and into position, so you'll have to use 2 or more smaller tanks. Here's where you can find the preferred fuel load calculator. Again, it's not brain surgery, but this app does this calculation for you quickly and easily. When you are calculating the amount of diesel you'll need to meet your runtime requirements, don't forget to include the oil in the existing day tanks or belly tanks. A project I did last winter involved adding 2 20,000 gallon main storage tanks to a facility that had 2,500 gallon base tanks. 2,500 gallons times 6 generators is a lot of fuel, and you can subtract that off of your runtime hours. However, all this fuel didn't get them through the February freeze last year, so they decided to add main storage tanks. So we know how big our main storage tanks need to be, and we know how many main tanks we're going to have. Next, we need to size the transfer pumps that will pull the fuel out of the main tanks and push it into the generator day tanks or belly tanks. Generators consume about 7 gallons per hour for every 100 kW of capacity, or you can just multiply the generator kW by 0.07. You want to apply a generous safety factor because you want to be able to top off a day tank or belly tank relatively quickly and let the supply pump cycle off. Preferred will typically apply a safety factor of 3.0 to 4.0 on top of generator consumption, and then calculate how long it takes each pump to go from 50% pump on to the 80% pump off level, and make sure that we can top off a tank in a reasonable amount of time. Don't forget, we're talking about relatively small motors, And there's not a big price difference between one pump size and the next size up, so don't be afraid to apply a generous safety factor to the size of the transfer pumps. Preferred catalogs and tries to stock pump sets from 23 gallons per hour up to 1931 gallons per hour. We can make larger pump sets, but they're just not in our catalog. We also have rotary screw pumps available for high-rise applications. So these are the available pumps that we can use, for an off-the-shelf pump set. Now that you know the size of the transfer pumps, it's time to design the fuel transfer piping. The diagram here shows how we would like to see the transfer piping done. Each day tank should be able to use either pump, and it should be able to pull fuel from either main tank. This way, a failure of a single pump or single main tank doesn't take down the generators. Tank select valves, usually motorized ball valves with end switches, determine which main tank is in service. We always want to pull from one tank and return to the same tank. This way, we can't use the fuel in one tank to overfill another tank. We have customers that say they want to be able to equalize the level in multiple tanks, or just want the ability to move fuel from one tank to another. However, our customers that have lived through long generator runs have found the best sequence is usually to pull from one tank until it is nearly empty, then switch over to another tank and call a truck or several trucks to fill the low tank. Then if they have a filtration system installed, they polish the tank with the new fuel before they put that tank into operation. Just in case you get a bad batch of fuel, which happens very, very rarely, it's a good idea to polish new fuel before you use it. This sequence makes it more likely that a customer will be able to accommodate a full truck and all of their fuel is polished before it is used, and it keeps the fuel turned over. After Hurricane Rita, a preferred customer in South Texas was on generator power for 14 days using this exact sequence. So you can use the preferred fuel system pump and pipe sizing web app to help determine the size of the suction lines, discharge lines, strainers, and anti-siphon valves for the new system. You can find the preferred fuel system pump and pipe sizing program by Googling preferred sizing calculator or preferred pump and pipe sizing calculator, or as Dwight Schrute would say, search engine preferred pump and pipe sizing calculator. So one other detail on the piping is we're going to need to add flow control manifolds to the day tanks, because before, when they were direct fill, the truck driver would pull right up to the belly tanks and fill them. The diagram shown here is the most basic form of flow control manifold. If you like, you can build on this by adding a second solenoid valve. You can replace the solenoid valves with motorized valves. You can add a flow strainer. You can add a flow switch, or you can add a site flow indicator. But what you see here is the most basic type of flow control manifold. The 3-valve manifold around the solenoid valve is very important. It lets you replace a solenoid valve without interrupting fuel supply to the generator. It also allows you to open the bypass valve and put a pump in hand to fill a generator in the event of a controls failure. I've never done a retrofit like this with underground storage tanks, so most likely you will be adding above ground main storage tanks and gravity return won't work, so you'll need to put a return pump on each belly tank. These are the return pumps preferred offers. In most cases, the 15 PSI discharge pumps will work, but you should check the pressure required to get the fuel back to the main tank. If you have any vertical distance between the belly tank and the main tank, that might put you into a 50 PSI discharge pump. But if everything's on the same level, you can usually get by with a 15 PSI discharge, smaller pumps. Pumps and piping come naturally to us mechanical engineers, but the controls involved in a fuel system retrofit can make or break a retrofit project. Belly tanks or base tanks sold for direct fill applications usually will not have enough float switches for remote fill applications. Most companies supplying pump set controls, preferred included, will not reuse existing belly tank float switches and controls. Often day tanks come with a little control package that might close a contact to let a pump control system know the day tank is calling for fuel. In most instances, Preferred will insist on putting our own float switches in the tanks. Overfilling a tank is a big deal, and we put a lot of thought into how we prevent overfills. This is the outline of the sequence Preferred uses for filling day tanks. When the tank level gets down to 50%, we bring on a supply pump and open the fill valve and start filling up the tank. At 80%, the fill valve de-energizes, and if no other day tanks are calling for fuel, the supply pump shuts off. If the fuel level gets to 90%, we sound the alarm, energize the return pump, and hardwire de-energize the fill solenoid. We hardwire de-energize the fill solenoid just in case somebody's got a pump in manual, and we can turn off the pump regardless of what anybody has done to the controls. If the fuel level gets down to 40%, we sound the alarm and energize both supply pumps to increase the flow of fuel to the day tank. For a retrofit, the key is we need 4 float switches in the belly tank. Most belly tanks purchased for direct fill applications will not have enough float switch for remote filling. And the OEM float switches are sometimes really cheap plastic assemblies we're afraid to reuse. So Preferred is going to insist on putting our own version of float switches in the tank. It's our PLS4 PLS series. So if it has 4 float switches, it's a PLS4. If the base tank is at least 14 inches deep, we can use 1 PLS4. Otherwise, we'll use 2 PLS2s. PLS switches are 1¼ inch NPT male connections, so we need 1 or 2 openings in the belly tank, at least 1¼ inch NPT. You need to inspect the existing day tanks to ensure there are enough openings. And if you are specifying a new day tank, belly tank, or base tank, insist on extra spare openings of at least 2 inch NPT that are accessible after the engine is put on top of the tank. And that's it. Except for the changes inside the belly tanks, this is almost like starting from scratch with a new fuel system. So from a design perspective, going from direct fill to remote fill is very similar to starting a new fuel system design from scratch. So case 2, adding another main tank to an existing remote fill system. We also see facilities that have at least 1 main tank and a remote fueling system already that need to add another main tank to increase their diesel storage and runtime. Ideally, we want to add the new tank in parallel with the existing tanks as shown. When we have 2 or more tanks, we want them to be connected using a suction header. This way, any day tank can use any pump to pull fuel from any tank. Redundancy is a good thing. There are a lot of reasons why the new tank should be added in parallel. The first is simplicity of design. Also, we want the ability for any generator to pull fuel from any main tank. We want true redundancy. Finally, one tank can be emptied and then refilled and polished while the generators run from another tank. With preferred node net controls, it's easy to add another tank in parallel. We really want to try to avoid doing tank-to-tank fuel transfer. Bear in mind, the new tank will need its own tank gauging and leak detection system, or it may be able to be added on to the existing tank gauge and leak detection system. A lot of the gas station type commercial tank gauges are built to handle many tanks, and sometimes there's the IO there already to do another tank. If the tank select valves are manually operated, no other changes to the controls are required. However, if these valves are to be automated, you may need to check with the existing pump controls company to see if they can handle the increased IO, and you may need a program change. Call the supplier of the pump controls, tell them what you intend to do, and ask them to quote you the change. A couple of slides back, we said we don't want to do tank-to-tank fuel transfer, but in some instances, it just isn't practical to add another main storage tank in parallel. Sometimes we're forced to put a new tank in series with an existing tank. If that is the case, we need to do tank-to-tank fuel transfer. Positive displacement pumps or submersible pumps must be added with the new tank to get the fuel from the new tank to the old tank. The fuel transfer process can be manually or automatically initiated. However, the pump controls must automatically prevent overfilling the old tank. What I mean by this is tank-to-tank fuel transfer can be started manually, but the sequence to prevent overfilling the downstream tank is automated and can't be bypassed. Human error is a common cause of tank overfills. So a PLS2 is required in the old tank we're going to be filling, so we need to make sure there's an unused tap in the old tank that's at least 1.25 NPT. Sometimes it's possible to add another tap to a main storage tank. It may be possible to add the tank-to-tank fuel transfer to the existing pump controls. Check with the controls manufacturer. Otherwise, Preferred will put a NodeNet controller on the new tank as part of the tank gauge and leak detection system, and the new controller will handle the tank-to-tank fuel transfer. Okay, case 3, adding more generators or boilers to an existing fuel system. This is the tough one. If a facility wants to add more generators or boilers to an existing fuel system, this should be designed by an engineer or done by a trusted fuel system contractor, and that contractor should really call Preferred to assist with the engineering. This project should start with an engineering review of the existing system. You need to determine first how many bungs are in each of the main tanks. Determine the existing line sizes and sketch out the entire suction and discharge piping system. Get the pump curves for the existing transfer pumps and figure out how much the existing pumps will flow. You can use the Preferred pump and pipe sizing app to determine flow capacities of the existing piping and locate possible choke points. You need to determine the flow requirements of the new equipment. The boiler nameplates should tell you that, or you can use our rule of thumb of 7 gallons per hour for every 100 kW of generator capacity. If the existing pumps and piping can handle the new consumption, then you got off easy. And this is part of the reason we recommend safety factors of 3 to 4 on supply pumps. So now the engineer who put a big safety factor on the original supply pumps, and they don't need to be reused, that engineer is a hero now. You want to pipe the new equipment in parallel into the existing supply and return headers according to our perfect piping schematic you've seen about 4 times now. What if the existing supply pumps don't have enough capacity for the new consumption you're adding? You can replace existing supply pumps with larger pumps and pipe new generator or boilers into the existing supply and return headers. There is a cost associated with the new pump set, but the piping is easy. Since you already traced the suction and discharge piping, you have the information to calculate if the existing piping can handle the increased flow of larger supply pumps. Or you can add another pump set in parallel with the existing pumps and tie it into the existing supply and return headers. This is relatively clean as well from a piping perspective and adds redundancy to the system. Or you can add another pump set to the suction header and dedicate the new pump set to the new equipment. With this option, you will be providing new discharge piping, but using the existing suction piping. So you will need to ensure the existing suction piping can handle the increased flow. If the suction piping becomes a choke point, it will have to be replaced, or the new pump set can have its own dedicated suction line if there is room to add more drop tubes to the existing main tank. I'm not a fan of dedicating a pump set or a main tank to a particular generator because you lose some redundancy. You can get into a situation where if a pump set fails, you'll have fuel on hand, pumps move the fuel, but those pumps aren't piped into the new generator tank. So a generator is cut off from its available fuel. This is an unlikely scenario, but we want to plan for it and avoid it if at all possible. A common reason to dedicate a pump set to a generator or generators is a minimum runtime requirement for the generators. However, this can be done easily with software. For example, hospitals in Texas are required to have 24 hours of fuel on hand for their generators. Sometimes hospitals will dedicate a main tank to their generators to reserve this 24 hours of fuel. Sometimes the drop tubes for the boilers are cut short, so the boilers can't use the last 24 hours of generator fuel. And then the drop tubes for the generators go all the way down, nearly to the bottom of the tank. However, the easiest way to do this is just to have Preferred program the pump controls to ignore boiler run commands if the fuel level gets below that 24-hour level that's reserved for the generators. So finally, case 4, and case 4 comes from Alex Canny, who works in the Northeast, and this is taking boilers out of a mixed boiler generator fuel system. This is happening in the Northeast as the distribution system for natural gas is expanded. Hospitals are converting their boilers to gas firing and taking them out of their fuel oil supply system. This may require no changes to the fuel system or pump controls, but now that the biggest users of diesel fuel are out of commission, the fuel just sits and degrades. Even with periodic generator testing, most generator-only fuel systems do not burn enough fuel to keep their fuel fresh. We've seen facilities leave their main fuel tanks half empty or less to help keep their fuel from getting old. But half empty tanks condense more water vapor than full tanks, and water infiltration is the main reason diesel fuel goes bad. We've also seen customers replace their main tanks with smaller tanks. This is expensive, and at the end of the day, the facility has less fuel on hand for an emergency. Fuel additives can prolong the life of diesel fuel, and there are companies with portable filtration systems that can polish a facility's fuel, and this approach works if it is followed. However, as consulting engineers, this process is out of your control. What we recommend is adding a polishing system to the existing main tank or main tanks that will keep the fuel fresh indefinitely. Preferred polishers range from 300 gallons per hour to 1200 gallons per hour, and the finer filter element can be as fine as 1 micron. Polishers are pricey too, but they are a convenient way to keep diesel fuel fresh. And now that diesel fuel is almost as expensive as beer, you want to treat it right so it doesn't go bad. Okay, so thanks for sticking with this webinar to the end. Preferred has a network of reps and sales engineers who can provide design assist for new fuel systems, or they can help with the design of a retrofit fuel system. You can email me and I will direct you to the preferred sales engineer in your area. We're going to take your questions now, and as I said at the beginning, you can put them in the chat box, or you can email me your questions directly, and we will answer them live on the air. Okay, thanks for sticking around to the end. And I think you might have gotten a feel from that. We pre-record that part of the webinar, and we're doing kind of a live question and answer now. And hopefully you kind of got a feel for the question, how do I add on to this existing fuel system? It has a million answers, so the answer just depends. It depends on what you've got there, what you're trying to do, and what equipment you're trying to add. There really isn't a one-size-fits-all approach. However, if you do a detailed study like we recommend of the existing fuel system, then it'll usually become pretty apparent which of these ways that we recommend that you need to go. Because the study will identify the choke points. It'll identify where your capacity shortages are in the existing system, and what needs to be retrofitted in the new system. I thought of a couple of common questions while I was watching this. When does a fuel system retrofit project require that a consulting engineer firm be involved? I think anytime you're adding another main tank, that it becomes a complicated enough project that you're probably going to want to get a consulting engineer involved, because you've got soil studies, foundation studies. The new tank has to be sited and permitted, and a good fuel system contractor can provide a lot of the information for that. But I think you're going to need a consulting engineer if you're adding a main tank. The other question I get a lot is, Does generator consumption vary by engine manufacturer? We throw out that 7 gallons per hour per 100 kW rule of thumb, and every manufacturer is a little bit different, but I would say that they're all within about plus or minus 5% of that 7 gallon per hour metric. So considering that we recommend a safety factor of 3 to 4, on top of whatever you calculate your consumption to be, that plus or minus 5% is pretty negligible. So uh, the 7 gallons per hour has not steered me wrong in the past. Okay. If we don't have any more questions, we'll wrap this up. So thanks again, everybody, for sticking around. And if you have additional questions, be glad to help you out. Just send me an email. Thanks, everybody.